Hello, welcome to today's live coding session, again on Kafka Streams-Cassandra-State-Store. And today's feature subject to this session is implementing the versioned key value store that was shipped with Kafka 3.5. A quick note, I'm planning to make this, take it in iterations. So this will be part one of the live coding of this feature. And today I'm planning to focus on the theoretical part, so understanding the feature and what needs to be done, and also to explore and essentially define the underlying Cassandra tables and query patterns to read and store data. So let's get started. Subject, version key value store. There's a KIP 889, which explains the entire feature version state stores. I will briefly explain what it does. So let's just start with that. So I will not explain the entire feature, just to set the context. If you have not heard of version key value stores, I will make it very brief. So until now, before or if not using version key value stores, just a regular key value store, the stores used by Kafka Streams maintain only the latest value that was processed for each key. And this prevents Kafka Streams from providing the proper temporal join semantics for stream table joins, and also other table foreign key joins, and it affects at different angles also aggregations. So it essentially cannot work or provides results in incorrect or inconsistent results for late arriving data. And here's the most basic example. We have a table join A join B. A is a stream, B is a table, and the records arrive in this order. So we first get B, which is the K table, at time 0. We get a first value B1. Then we get a stream value for A at time 1 with the value A1. So we can match A and B, and which results in an output A1, B1 of those two values. Then there comes an update for the table B, all kind of now with a kind of the same matching key at time 3, which is the value B3. Then, since it's a stream to table join, we only emit values if there's a message coming in for the stream for A. So there's no output, just the table is updated. Then the next stream record arrives for A at time 4 with the value A4. So we do that join and we get an output A4B3. And now comes another record A, which arrives late. It comes after the record for time 4, but this record has time 2, so it's a late data with the value A2. And the output, if not using version key value store, so the old world, results in A2B3, while it actually should be A2B0, because at time 2, this record is not valid yet. So at time 2, the result should be A2 and the value from this record, which would be B0. And that's it in just as that walkthrough of that example. I will not read out now kind of all of the remaining bits, so just read the KIP if you are interested or have not heard of version key value stores before. And even better, there was a talk at Kafka Summit London 23, which I can highly recommend if you have not watched that yet. And there it's you can watch it for free. It's presented by Victoria Xia, and it's a very interesting talk with a great Q&A at the end. And I'm also, just highly recommend. It's well explained with all the different details on how to also use version state stores and all the edge cases and limitations for now. So go and watch the talk. I'm also going to reference some of the slides for the example and to design the table today. So let's just continue and start walking through an example. Actually, not sure how to continue. I think it might be interesting to also take a look at the new interface, versioned store of the versioned key value store. Again, I'm also not going to read out all of the Java doc. So I will just skip through and we are going to look at the methods. First one is put. So in contrary to the regular key value store, it does not only take a key and a value, but also the timestamp, which is obviously the timestamp for this record version. Then we have a delete, which also, besides the key, takes a timestamp. So the delete is also obviously referencing to delete a record at a point in time. Then there's one extra method without timestamp. This is just a regular get, and it will return current value, while there's also the get as of timestamp when you want to query your value for your key at a given point in time. So this is everything that the interface provides right now. As the KIP and also the talk point out, interactive queries are not supported yet. This is going to be provided with a future KIP, which I think does not exist as of now. So this is in the future. So for our implementation, we're also just going to have to solve and fulfill those 4 methods of this interface. Okay. What comes next? Let's just look at some of the slides of the talk from the Kafka Summit. And I think they make a good example and provide some details on how it works under the hood, how this is persisted, and obviously also allowing or guiding us for implementing this with the Cassandra-State-Store. So here's kind of a timeline with obviously the times at the bottom. And we're in this example, we're just looking at a single key. And this green green colored records is essentially the values over time. So at time 0, a query costs $8. Then at time, 4, here we can see at time 4, it costs $10. Then it's updated to $12, $11, and $9. So each of those values or inserted price for the query essentially has boundaries. So it has a valid from and a valid to. And if we look at kind of the state over time, when we have all of that already present, then we can say the latest value is $9, and that's from the time 53 until essentially undefined. So this is our latest record. We have valid from 53 until like eternity, for there's no more recent data than this. Then the previous record is valid from time 38 to 53, and here 70 to 38, and so on and so forth. And this essentially makes it necessary, or that exact detail that we have to consider and store valid from and valid to along with our record. And secondly, if we would, this obviously makes a lot more extra data, and to prevent having to store like all of the versions and everything, which also comes with performance impact when you query data and all of that. It comes with a setting for the history retention. So how far back in time reads may occur. So if you join data, remember this is for solving late arriving data, and not for essentially providing like a forever valid like entire time span point in time lookups. Or I guess you could configure it with a high history retention, but I think the usual use case for version key value stores is to just solve that inconsistent data problem for late arriving data. And usually you have your late arriving data in kind of a short span of time, which you might get them in. So you don't need to consider like minutes, hours, or even like weeks or days past the current stream time. So let's look at that exact example provided when you would do a lookup for your state with this kind of set of values for the key query and this history retention time. The first, this is what we're gonna kind of try to achieve also with our Cassandra table, and prove that the concept and the CQL schema and the query patterns will all allow to fulfill this use case. So if we just call get key query, so we expect the current value, this would be $9. So at the stream time here, if we say get key query, then we get $9. If we want get query as time of 60, that would be this point in time. Again, $9. If we would get it at 50, expect $11. If we look up query at the time of 35, which is before essentially history retention window, you could think it only would contain those two values, but that's not true. Essentially, what the historic retention includes is the boundary is essentially the valid from. So obviously you want to know at time 35 what value you've had at this point in time, which was $12. And only if you query outside of the historic retention window at time 30, then we say this is we don't keep records that far back, so we cannot answer that request. And the same goes for writing data. So if we say we want to put query a new price $10 at time 25, and this is outside of the retention window, then we simply skip and ignore that record, because it's It's just now too late and not within our retention window. Those are some details we also obviously then need to recognize and implement the same way. So this is more going to be a bit of a future implementation part of validation and logic, working with that history retention window. So far for the details. And there's one more slide which is more focused on the implementation side of the RocksDB implementation, and the same goes for the in-memory, but there's so far with Kafka 3.5 only an implementation for RocksDB, but that pattern essentially is used for both stores. And for windowing and windowed stores, and also this new version store implementation, Kafka or Confluent has implemented this with using segments. So you have a fixed segment window size, and essentially all the data is stored or placed into segments, time-based. And when you kind of parse your retention window, entire segments are dropped. And if you want to learn about all of those details, again, this is from already existing talk by one of the developers implemented or closely involved with Kafka Streams and KSQLDB. So go and watch the talk to get all the details. Just one quick note, our benefit with using Cassandra is essentially that we do not need to use such segments, because our data is already partitioned, also including the timestamp, or it allows us to define primary keys that use not only the key or the partition, but also timestamps, part of the primary key, so we can work, I would say, more efficiently with even Cassandra as the storage backend for the state store. So let's see how this is going to work out. Okay, so much for the theory. So time to get our hands dirty and get started. So let me first simply run Cassandra, a new Cassandra container in our local Docker. And we're just going to directly exec and run CQL sh into our container once it's ready. And I just prepared kind of the most basic key space named test with a simple strategy. So I'm gonna not kind of work with a cluster, but with a single container, which will be obviously sufficient for our data modeling exercise. While this is starting, let me also quickly mention I'm not like totally unprepared. So I've done initial draft already, but we're still going to create the table from scratch again and walk through all of the access patterns. And then what I have not done before is to actually just manually insert data and walk through the example from the Kafka Summit Talk, and based on that evaluate if we can fulfill and get all of that done with our new defined table. So I think the container should be ready. Okay, here we are in our shell. Let's create the key space. That's done. obviously we would next say we use test, and then we can start creating the tables. And let's just start off with our existing tables. So again, we have two variants or types of Cassandra key value stores. One is a partitioned version, and then we have the so-called global version. The difference is the partitioned is closer to like how RocksDB and in-memory stores operate, where the partition of the message, the Kafka partition, is also written part of the record in the Cassandra table and also used as the partitioning key, which allows for like range and prefix scans based on the key. And on the other hand, the global key value store simply does not use or have any information on the Kafka partition of our store value, but directly uses the key itself as the primary key. So those are kind of two types with different limitations and benefits and drawbacks. I have covered all of this in a prior video, multiple ones. One is the introduction, and another one is also two are focused on interactive queries. So go to the YouTube channel and you can rewatch those if you're interested in more details. Okay, for our version key value stores, we're also going to provide version key value stores in both flavors, in partitioned and global. So let's just start with those two non-partitioned, non-versioned tables, and add the new fields required for the versioning. Okay, so let's start with the partitioned table. And essentially, as we can see here, we have valid from and valid to, which we need in addition. So what we're going to do is just going to add two new timestamp fields, valid from and valid to. And since we also need those to query and access our data, we are going to add them to our primary key. And if you have watched the talk, and essentially I have modeled this before, we will walk through or get to the detail of that. We are gonna not use the valid from, but the valid to query our data. So we are just going to add this as a new clustering column to our primary key. And in addition, just to be more concise, I think this is, let me quickly look that up from my draft. We also need to add just the clustering order of the clustering key. So we say the key actually doesn't really matter, but we keep it ascending, which would be the default if not defined. But the valid to we want in a descending order. So this affects how the data is persisted and kind of the default order in which data would be returned when you query by partition and key. And yeah, we keep the compaction. So this should be everything for our partitioned table, and we can do the same for the global table. We add, let's also keep them after the key. We add valid from, valid to, and now we also make the key as our partitioning key, and we add valid to as clustering primary key column. And we also then have to add the clustering order just without the key, because the key is the partitioning key. So the only clustering column is valid 2. And we're also going to make that a descending order. Okay, and I think that should be valid, a valid schema definition. So let's just create those tables and see if we did not make any mistakes. No, we did not. So we can create both tables. Okay, first step done. Let's just work. Yeah, let's work with the partition table first and essentially check all of the query patterns we will need to satisfy and implement our interface and the state store on top of this table. Let's before we do that, let's just start with some test data. So obviously we can just select data and we can insert into IntelliJ, being amazingly helpful here, providing proper SQL auto-completion. So we say just test data partition 0, key would be text as blob, let's say of string 1. Oh, let's stick directly with query. As in the example, valid from would be 0, just say 0 to 10. Time is 10. And the value would be, just say int as blob of, I don't know, $8, I think was the example. So if we insert that works. If we select, we can see our data. And I think it would be more appropriate to say we just select partition. Then we say blob as text of our key. We have valid from, valid to, was it time? Yeah, time. And then again, blob as int of our value. Let me just move that further to the beginning. If we run or execute this select, we can see partition 0, key is curry, and our value is $8. And well, the valid from is here printed as directly as a date, but this is also helpful. It's not. Well, I guess it's fine. Maybe we can let me clear this and let's just say we work with, I don't know, at least in milliseconds. So let's make the test data like this. And if we select, yeah, I think this is a bit more readable. So we have valid from here 0 and valid to 10 seconds. Okay, so we have a first test record in our new table. Now let's head back and essentially take a look at our access patterns we need to support. Let's start with the most simple, our get current value. So we want to query simply by key, and well, for our partitioned example, we will also always know which partition the key or the store is initialized with. So we would essentially say we have a select, like all of that, where partition equals 0 and the key equals text as blob query. Now, obviously, if we run it like this, we will get an error. I don't know, mismatching input. Not a comma, and different error. No, we actually are able to select data, and we get a single record, but only because we only have a single record in our database. But essentially, since we are not using our valid2 field, we do not exactly do a primary key lookup, but we do a range query. So we get all our versioned records for our key, which is not what we, at least not exactly what we want when we always want to get the current value. Now, I think we start to need to prep our example data a bit more concise, because how we can see in our example here, we essentially inserted a record, that first record. But when we say we want the current value, we essentially expect our record to be valid from some value and valid to undefined. Now, in Cassandra, we cannot store undefined, or we cannot store null as a primary key column, but essentially we will simply define -1 as our unbounded valid2 value. So essentially, we will need to do another insert and say valid from, as our example, 10,000 to -1, valid2, at the time, whatever, 60 seconds. And now we have a record with the value $12. If we insert that, again, if you would run that select, now we get both records back. But if we only want that latest or the current value, we essentially just need to select also using and valid2 equals -1. So this is kind of the first, this is also how the implementation of Kafka Streams with RocksDB works. If you have a single record or whatever, if there's a record, you will always have a current value store underlying of the state store, a current value, don't know how to call it, bucket store, I think it's also called, which will always hold all of the current values by key using a valid2 with the value -1. So if we now run this query, we will get a single record, and this is always our latest value. Okay. So that's essentially our first query pattern done, and it's an exact primary key lookup, so it's highly efficient. It will go exactly to your record with all of the primary key columns used for the query. So it's perfectly efficient and solid. So first part done. Let's take the second example. Again, referencing to the to the Summit Talk, and in particular to the Q&A session, it's mentioned that the RocksDB implementation works like that. If you say get me the value at t30, how it works is you always first look up the current value. The current value you then check if the valid from is before the time we want to look up. So if we say get for time 60 and the current value says, maybe let's use that example here. If we want time 60, we always first fetch the current value. And if that says valid from 53 and our time is larger than 53, then we know, okay, this is exactly what we need. We can already fulfill that information. Now, if we say we want t30, we query that first value and we can see, okay, the value for the time we need for is before this current value, which is only valid from the time 53 onwards. So we need to look before that. And due to the nature of using those segments, how RocksDB, or how this is implemented for RocksDB, or probably also going to be for the in-memory solution, they need to iterate backwards, linearly walk backwards until and query each segment until you find a record that fits the exact time frame you want to look up. Now, this is now where I think we can solve it more elegantly. Okay, so let's say we now want to fetch at time. What test data do we use now? We say from 10 seconds onwards, we have a new value. So let's say we want to fetch at a time before 10 seconds, at time, I don't know, 5 seconds. How would we query this? Essentially, we can do a range query. So let's just start with this select. So we know our data is in partition 0. We know our key is curry, and we also know from the method that we want our value as of timestamp, like with a exact value as a long. So and we have our valid 2 part of our table. So I think we can do and valid 2 is smaller or equals our 5 seconds, which would be our for this purpose as of timestamp. I think we might need to double check the exact boundaries. If we would query for time 10, I think then essentially our latest record should be the one to satisfy, but we're gonna always query the latest record first, and then we will see that this fits. But I think we still would need to say valid 2. Yeah, I think it doesn't matter if we use a smaller or equals, or if we should use a smaller than 5. I think it shouldn't matter if we persist the data correctly. But if we now say we execute this query, this is a valid query without filtering, the need of filtering. We will we get our record. Let me check. Right. No, I think not quite. What we see now is $12, but I was expecting $8. But the problem is that I was using -1 as kind of the unbounded, and obviously -1 is also smaller than 5. So I wonder if I should use a max, the maximum, I don't know, max long, max int value, but I'm not sure if I like that approach. I think essentially we could also say and valid 2 smaller or equals 5 and also greater or equals 0. So with this query, I'm not sure if that might have a performance impact. I think it should not. Okay, no record, no data. Let me think, did I make a mistake here? That from valid 2. Let me double check what I had done in my draft. I think I might actually might have made a mistake when drafting this, because obviously now we have our record valid from 0 but valid to 10. So we think if we just need to change our query, maybe it would be better to, let's stick with that simple example. So we use valid 2. If we say we would simply turn it the other way around, we would anyway always query the current value. So we will get back kind of current is valid from 10. So we could say we query, we know we should have a valid 2 before that if we have a private record. So we would say valid 2 I think we actually can say valid 2. No, we cannot say valid 2 equals smaller or equals those 10, but also greater or equals 5, which is our boundary where we want to look at. So now we should at least get a record. No, still no record. Why are we not getting this value? So valid 2 is 10 seconds. I'm working without not in milliseconds but in seconds. This was a mistake. So we need to make that milliseconds. Okay. Try that again. Okay, we get our correct value. Did I make a mistake that before with the prior approach, if we say valid always greater or equals 0, but we use here our 5 seconds? No, that still won't work, obviously, because this record here has a value which is greater than 5 seconds. So I think actually this is wrong, but this should actually work. Now, I think now it might, again, the next step or edge case we need to consider is if we have multiple values, not only a single one, which obviously will now be returned, but if we have many values, not only one at 10 prior to 10 seconds. Let's make more test data. Let's say from 0 to 4 seconds, and we have 0 to 8 seconds. Not 0, then essentially 4 seconds to 8 seconds. And then we have 8 seconds to 10 seconds. And let's say we have simply $8, then how can we, let's just take that seconds so it's easier. $4, well, $0 cents, but $4, $8, and $10. Let me just truncate again and reinsert all of our new test data. So again, we want the latest value, then we will get our $10 now, which is our latest record. And if we now say, let's just execute that and see what we get multiple records, exactly because we now get 2 records. One is valid from 8 seconds to 10 seconds, and one is valid from 4 seconds to 8 seconds. And the one we actually want or need, the correct result would be here, the second record. Because this is the one which is, would this always be valid? I think so. Yeah, this is the one valid to 8 seconds and which is larger than our time as of. And it's not superseded by or any prior value. So what we actually need to do is we say, what if I made a mistake with clustering order? We say order by let to ascending, and we say limit, we only want one record. Because we don't need many of them, we just need that exact record that we want to satisfy our get value at time of by key. And in our example, that now would be $4. So this should be, I think this should be the right query now. Let's just stick with that and test out that that full example used in the Kafka Summit Talk later. Okay, interesting. And let's keep a note that should the story ought to be use it to ascending. And the same would go probably for the global store as well. Okay. That's our second method satisfied. And now it will get a bit more interesting. And I think not only by, I think here we probably won't need to change or test anything related to query patterns, but rather to the process involved when we need to insert records, or when we need to delete records, which might be a point in time record. I think it might still be. Let's play that through anyway. How we need to handle that. Or could we do that along with building up that full example? Let's do the basics first without that example. Let's just say we have this existing state where we have our latest record from 10 seconds onwards. And now we get a new latest value, and it's also not an out of order value, but we get, let's say, new insert at time 15, price $15. So we have, what do we need to do now? Actually, not just like looking at the table. We could obviously manipulate our test data here, but that's not how it's going to work in our like actual implementation of the state store, because we won't know our data unless we query for it. So essentially, what we need to do is step one. Step one, get latest or get current value. So we would query again this. So we know our record valid from 10. And what we now need to do is to essentially write our new latest value. So or I think step 0 essentially is validate time is not is in our retention window. Let's say we have a retention window of anyway, I think I'm going too far. Let's do that later. I will still keep it here. Let's say we have 30 seconds, so it's larger than everything we have. So this is just valid. So we don't need to skip the record. Step 2 is to get the current value, and that we have new record is after current. So we need to replace the current value. So the step 4 would now be we need to update previous record, and also insert due record. And to make sure this, like, not only one of them succeeds, I think we should actually use batching. But let's for the purpose of our first test run, let's simply not use a batch, but let's say we would need to, essentially we don't update records if the primary key is different in Cassandra. So this is more kind of the logical step 4, how that works, that we update a record. But essentially what's actually going to SQL is we need to upsert current. We will update the value and the valid from. Oh no, it's actually, no, what? Sorry, check it from. Okay, now I think we need actually to delete. No, valid from is not part of the primary key, so we will update the value and valid from columns and insert the previous record as a new row. This is how how this is going to look like to Cassandra. So we would actually just simply do insert into word count with starting from 15 seconds, to -1, so valid from 15 to unbounded at the time of 15. Our price is $15, and if we now execute this insert, then it's actually simply going to work like an upsert. So it's going to replace the current value with partition 0, key, query, and valid to -1. So those are the primary key fields. It's simply going to replace the previous latest with our new value and valid from. And then we also need to insert essentially that update to the previous value, where we say this is valid from 10 seconds to 15 seconds. Time of this record was written at 10 seconds, and the price was $10. And since this valid to 15 seconds was not known to the Cassandra database before, this combination of those 3 columns making up the primary key, this is essentially a new record, while this is rather like an upsert of the existing current key. So if we run those 2, and we would now do, and we get that information valid from, obviously from our prior select. So we first need to do a lookup. Then we determine that the new record is after this, and then we need to patch. And if we now do another kind of get latest, we should see our $15, because this is kind of the valid to -1, which is here kind of determined before midnight of 1970. Unix time 0. So this works. This is fine. This is our put for a new current value. And I think we could play through a put for our let's also do that. So we now say we insert. Let's quickly finish this with batching. Batch updates don't have. We just look up pattern. Don't have it remembered. Batch statement. Batch begin. So we would do here batch begin batch and do our 2 inserts. It's also going to hit obviously like efficient the same partition, because the partition key of the primary key is the same. It's the same. Yeah. So it's a efficient, valid use case for batching, and this will ensure that either both write operations succeed, or it fails and we roll back, so we don't leave with a inconsistent state. So again, if we would do that with the batch, that well, it just works, or it doesn't complain at least. So that should be fine. Okay. Now I think we said we just play through an insert at time 12, price 12. We would get again, first step, let's say this is kind of new current. Now we have like a late new late record. First step, validate. It's within 30-second window to our current stream time. And 15 seconds. Let's say we say now stream time stream time 16. So this is still within the window. So this is fine. We start again to get the current value. And the current value will now return current is valid from 15 seconds. So our new record at time 12 is before. Let's put that together. So step 3 is new record is after current is now false. So I think what do we need? I think we might need to actually get our record at at the point in time 12. It's interesting. I thought, oh, maybe it would be more efficient instead of fetching the latest record first if we directly. No, I think, not sure. Let's think about process flow later. And now make a second select at the time. What did we say? Valid 2 would be smaller than the current, but it would be bigger than 12. And we want the lowest valid 2 that fits within this definition. I wonder if we even need that valid 2. Let me quickly try that with the current demo setup. If we just say we remove the first condition, which doesn't really make sense, but because we order by valid 2 ascending anyway, limit 1, I think that should return the same result and one condition less to check. Yeah, I think this is just put the update this information. Okay, so we have simplified that a lot. Again, then we can also remove that here. And we should now get our, record, this one essentially, which is valid to 15 seconds and has, the price was $10. So, yeah, correct record. And I wonder if we then even need this lookup, or if we could also directly use this. Valid to, no, I think because the current record is always valid to -1. I think we still need to do 2 lookups. And I think it's highly, if we don't have too many late arriving data, which you usually, depending on your setup, but I think it's more uncommon to have an out-of-date record coming in. So most of the time, that first step might just return valid, and this condition in thread step 3 would most of the time it would be true. So now step 4 here would be fetch a record. What was it called? as of timestamp 12. And here we get our record $10 minute from 10 to 15 seconds. This is what we get back. So what we need to do is we need to now again do an update. Step 5. Just call update previous. Well, it's the same step as before, essentially just that the previous record is not the latest, but some in-between point in time record. So we would still simply use a patch insert and say we now have our that record we fetched was valid from 10, but now not to 15 seconds, but to 12 seconds at the time, written at the time of 16. This is our, no. When was this? This was I think this was written at time 10. So we're not gonna fiddle with the time of when that record was originally created. So this is this one here. We just queried. So this time stamp we are gonna change, even if this insert will actually create a new row, but we will still keep this, and this was a price 10. And we then insert a new record valid from 12 to 15. Here is, I think, why we also actually need that. We might not know, there might be other records in between. I don't know, we get that from this previous record, obviously, which was valid to 15, so we can we do have that valid to value. This was written at time 16, stream time 16, or the record time. Let's say, I'm not sure what information we will get here, but I think we will write that as of time. Let me think. I think unfortunately, the state store interface does not provide access to the record time. So I think what I use in writing this is simply the current timestamp. So let's say we would also insert, as of our example, insert time 16. I think this is also not really actually used anywhere. It's just for information. And unfortunately, there's nothing to be done other than inserting the time as of when writing to the database. So this is always kind of the system time actually. Because there's no access to the stream time or to the record time, none of them are available within the state store or the state store context, unfortunately. So let's just assume we get that record, we process at the same system time as the stream time, which might not always be true, most likely not. Either it might be a small diff with whatever your latency to your latest offset is, or it could be if you reprocess data, it could be any time in the past, the stream time compared to the system time, but this is nothing we can do. Too much detail. So let's say this was our new record, $12. Let's finish with the example. So we update our previous record, which was valid from 10 to 15 at the price 10, which will now only be valid from 10 to 12 seconds with the price 10. And then we have a new record from 12 seconds to 15 seconds at the price $12. We do that batch update. And if we now query, I want to get the value at the time 13 as of time 13, then we should get $12. Here we go. Okay, that's our put. And I think it should essentially a delete would be fairly similar. A delete also comes same with the put, just without a value with the timestamp. So let's just say we delete again this record we just that just came in. Let's say delete record, delete value at time. Let's just say this time 13. So again, step 1 would also be we validate time is in our retention window within the retention. Let's say this was done at stream time 17. We get a late record to delete at 13. Yeah, delete the value at time 13. And say we process that at the stream time 17. Yeah. So this is true, obviously. And now we would, let me think. let's just start with get that record at that time. So we get record $12 at valid from 12 to 15. Okay, and this record we want to delete. So we not only need to delete, but we need to update the previous record as well, because we would undo what we did here. Here we update that record that was valid from 10 to 15 to 10 to 12, and now we need to undo that and essentially restore the record, the previous record, which was essentially this one, 10 to 15. Now let's see where we get that information from. So delete versioned record, update the previous record, which will now be valid for a lower time span. Okay, we would again batch. We would end with apply batch, and we would definitely insert or insert upside whatever that previous record, and we would delete from where partition equals 0 and key equals query and valid. We obviously need to do a primary key delete, so partition 0, key query, and valid 2 needs to be exactly. We know we not want to delete this one, so the valid 2 would be 15 seconds. So we first do the delete. I wonder if we send this as a batch, if they get executed in order. I think it should, because it's on the same partition and key. Ooh, that's some detail. I'm actually not quite sure what would happen if the insert is applied first and then it's deleted. I think I will add a to-do ask. If this will be applied in sequence properly, or if this could somehow end up with an invalid state. I actually don't know how this is applied under the hood, but since it's affecting the same partition and therefore the same node that will process those operations, I would expect that to take place in the sequence within the batch. But better to be safe than sorry. Okay, now back to our values we need to put in. Obviously, we know we have queried the previous record, that we need to add that current record, the record at the time 13, that we need to delete. So we have all the fields, partition, tag, key, and valid 2 to execute a delete. But I think to do that insert and patch that previous record, which was valid from 10 to 12. We don't have this valid from value yet. So I think what we need to do is we should take that valid from the record we are about to delete. And sorry, I think I'm incomplete here. Step 2, fetch as of time, stem 13. And this would be, and I think here is essentially here another step 3, which we have done, is fetch record as of time 12. This is the valid from of yeah, I think that should be good enough. This is the valid from as of this record returned here, which is 12. So we do another select. Wait. We do the select here, time 13, and then so this should return $12. But if I do this select, this should return, yeah, exactly. Okay, this was our old statement. We get our $10 record, which is valid from 10 seconds to 12 seconds. So we get our record $10 valid from 10 to 12. And with this, from this record, we actually need that valid from. No, we need the, sorry, we need, so we delete this line and we then insert, yeah, we need the valid from, exactly, okay. The valid from and the valid to we get from this record. So we take that, the new window boundary, valid from the previous and valid to the record at that time that we delete, to kind of restore this entry. And I think we are not done yet, because we still have this. We still have a record that is essentially this one, which is valid to 12 seconds, which we are updating here. But updating is not it's not an SQL relational database. This is Cassandra, so this is not an update. It's just a new insert. So we actually need 2 deletes. We delete the latest record, or not the latest, that current record, and we also need to delete that previous record, and then we reinsert the previous record with the new correct boundary from 10 to 15 seconds. This is what we should do, and this is step 4. Delete versioned record. Delete and we insert kind of a new previous. So this is those 3 sub steps under step 4 with applied within a batch. And after that, we test at the time. What did we get? Delete value at time 13. So we test again time 13, and we would expect $10. What did we do? We expect $12. It's called assert. So let's apply that batch and do the select. Ooh, empty. Okay, here we go with that answer. If the deletes were applied after the insert. Okay, now this makes it a bit of a problem. Let me try again if that's even like random behavior. I think the problem might be that with that batch, this is using the same timestamp. So each row or each row in Cassandra table also has like a row timestamp, which is not, you can query it, but it's not visible if you just select like your usual data. I think you can also select it, and there it's probably putting the same time for all 3, and then I'm not sure if then the thumbstone essentially supersedes the insert. So maybe we can even, I think one option would be if we now just move that batch outside and do it after, then it should work. But then again, we lose that consistency if whatever the process dies or one request or the other does not reach database, or I don't know, anything goes off with the Cassandra cluster and only one of them is applied, then we have like an inconsistent state. But anyway, if we do that insert and then do a select, we get our $10 record that we expect. But if we do it with that batch, then we again will have no data. So I think there might be a trick to this. So I'm not sure if that's possible with a batch. Let me quickly data stacks, inserting data. More time to live. Let's see if we can find insert timestamp. I think you can define the timestamp to apply. Timestamp column. This is not what I'm looking for. write timestamp, CQL. Write time. Querying data. Um, yeah, this was what I was looking for, using timestamp. Let me see if that works. Let's just query. I'm not sure how time. Let's work with, for the purpose of this example. Sorry, let me again fetch. Select write time. Let's just say we do again this this insert, like quickly outside for the test purpose. And then write time of the, I think it shouldn't matter. So let's also fetch the write time. Well, let's put it at the end. Let's do quickly do the insert. Not sure if you know what I'm trying to get at, and then let's fetch. No, that's right. Primary key. Or let's use whatever time value. Write time of value. Okay. Okay, here we have a write time. Just wanted to get somewhat of that current time, milliseconds. Maybe I could also don't know how to get up within CQL. Could have fetched Unix time or something, but let's say we do that delete, we do that insert. Okay, so what I want to do is let's quickly apply that batch again and confirm. Then we have a empty result. Yeah, and let's now say we do use our stream time or current time, which are anyway I hope now this should be fine. I think let's say add what was it? Using timestamp this, and we do that deletes using timestamp like 1 millisecond earlier. Not delete. Oh, I hope the delete accepts that. Oh, it might not. Oh, okay. Next problem. Let's see if that applies. No, it's not. Okay, I think this might be a bit of a problem that you cannot work within a batch, operate on the same row essentially. same primary key, which would be this one, which we then also want to write to, not only delete. Within the same batch, I think that might simply not work. Maybe there's another solution, but I think I might need to put that on hold for now. And do that in a separate step. Actually, what I think I'm just being ridiculous here. I don't need to delete that record at all because we're gonna overwrite it anyway. I was just being stupid here. Oh my god. Okay. So essentially, we just need to not delete this record. We need to delete this record, but this is not necessary. Stupid. Required. Because we're going to up. Okay, so actually I think this is good news anyway, even if I wasted some time, but that's part of the game. Now we should, why not? Timestamp. This can that. Odd. Okay, let me again. I think I might have a delete thumbstone in there from another try. Yeah, now we get our correct result of the new updated previous record, so to say, which is valid from 10 to 15 at the price of $10. And let's clean up, remove that write time bit. Okay, now I'm glad that there's no blocker with the batching, and we can also properly kind of handle that delete of a point in time within a batch. So we need to do two queries. Did I also test the delete of the latest? I think if we delete the latest, it will be simpler. I think when we do as of timestamp, like as of times, I think actually, what would happen if we say as of timestamp 20? Then we get our $10. We don't get any data. Right, okay. Because obviously our latest record is valid, which has a -1. So no, I think actually we need another step. This example was at time 13 with having the knowledge that it's not the current value. So I think actually this is fetch current record and check if valid from is smaller than 13 smaller or equals 13. So we actually do our lookup with -1. We see the current is valid from 15 seconds onwards, so this is not the record we need to delete. And then we essentially have our step 3 fetch the record as of time 13, and step 4 and step why is there a step within here? No, the batch is below. Okay, so we have actually 5 steps for queries, while one of them is a batch. So yeah, version state stores is not going to be cheap, but that's the nature of having those historic versions and kind of fiddling within that history by either updating, inserting in between, or deleting records at a point in time. So yeah, this is kind of the procedure, the process we need. And I think with that we are through, at least with everything we need to implement all of the interfaces. So we have confirmed the Cassandra table, the new schema with new fields and the new primary key. We have verified or established all of the processes to retrieve data and also to put and delete data, either the latest values or point in time values. And so I think from that perspective, we're complete. What's missing though is what we did not look at least for now, is to what we did somewhat consider the historic retention in kind of that nature that we skip records, that we validate our incoming records if they're within that window. But what's missing is kind of cleaning up older records as we move on with the stream time and kind of pass stream time minus retention time, pass beyond historic values in the database. So we also need a procedure for cleaning up data. So if we say for that, if we do the select without order and limit and valid to restriction, we have obviously a whole array of values for our key query. Right now, I think we have them ordered top down, while the latest value is at the bottom because we use -1 as the valid 2. So I think we need to say clean up. I think essentially, since we can query with a range, if we say we want all the records just say like all records, all historic, all versioned records for key, we have that select. Let's say all versioned records for key before valid to I don't know, let's put it here 6 seconds. Not sure how many records we would have. I think maybe 2. Then we would say select where the end valid to smaller or equals 6,000 milliseconds and valid to larger or equals 0. I don't know if we could also say does not equal -1. Maybe that's, I don't know what's easier. Probably both would work. Like this? No? Unsupported relation? And not valid to equals -1. That should be the way to do it. Also not. And not, I don't know. Then let's say larger or equals 0. Let's just go for that. Okay, we have a single record which is valid from 0 to 4 seconds. That's correct. If we would query anything before 10 seconds, we would get valid to 10 seconds, 8 seconds, 4 seconds. So 0 to 4, 4 to 8, and 8 to 10. So this is also correct. Which essentially allows us to run that same query, not with the select, but cleanup. So we just do delete from count stream store where valid to is smaller or equals 6 seconds and larger or equals 0 to not delete our current value. And yeah, if we would make that like 9 seconds, that should delete those 2 records. So we can use that for a cleanup. And I think the question now only is when would we do the cleanup? We could do it like with any access to the state store, or we could use punctuate. I think that's probably also not how Kafka Streams with the RocksDB implementation is doing it. Usually they only take action if a message is processed, and therefore kind of the store is processed. So I think we should probably apply the cleanup. I think I would not apply it after retrieving data, but we can apply it after we put data or delete data. We can, after all of that, kind of what we're doing here, we would simply also execute a cleanup based on the current time minus the retention time. Not sure if that makes sense. Not sure how to explain it. So if we process a record at time, I don't know, 65, we would insert that new record and update the previous record, and all of that we need to do anyway. And after that, we could say we delete everything for our partition and key, and that has a valid to smaller than like 65 minus 30 seconds, so smaller or equals to 35 seconds. And that would probably here in this example be the first 2 entries, because this $12 entry will actually have has a valid 238. So the valid 238 is larger than 35 seconds, so it will not get deleted. So we can still read our record at time 35 or 36. So only those two would apply for the delete in this example. So I think for the cleanup, this is also this is a single step, so it's not it's a single range delete, also without filtering, so it should still be efficient. It's clean. It's all safe, and we only need to calculate the correct valid 2. Okay. I think with that we are actually. I think with that we are good. Actually, I'm not sure about this to do, if we should use a valid 2 ascending or descending order. I think for our purpose until now, we actually would use ascending order as part of our lookup queries. So it would probably be the better choice to use ascending. I think I know for ScyllaDB that it actually doesn't matter if you retrieve data and the clustering order is ascending or is descending, and you query by ascending. I think with some of the 4.6 releases or similar, or 4.5 already, they, or was it 5.0? I don't know, but they made a big kind of improvement on that part, where I think it doesn't really matter. It's equally performant either way, even if you go against kind of reverse order of your defined clustering order. But I don't know how Cassandra handles that, if it has like an impact on performance, but you probably won't have, like, for a single key, like, not thousands of versioned entries. I guess you could, depends on your workload, but I think it's more likely that you might have like a reasonable amount and not millions of rows, so it might not make any difference actually. So I think it might be better, and it depends on what interactive queries interactive query methods will be added with the future KIP. So I don't know if there's going to be any access method to retrieve like all versioned historic values for a key, and then in which order. I don't know if there would be ascending or descending, or I don't know if that would really be. Let's just wait for that, and if it would actually be a problem, or if anyone even would query that. So I think we actually just go for ascending order. Let's say Okay, so let's go for ascending. I think then we could actually skip it entirely, because the default would be ascending anyway. So I think I'm just going to remove it in that case. to simplify that part, and I think with that I'm somewhat happy. I think I need to update. Either update or succeed what I had put in here. For I think this is no longer complete with all of that detailed work through done now. But I think I will update that later, since the recording already got quite long, and I need to see how I clean that up. That might be too much. So I think what I actually planned to do, I thought it would take less than an hour, all of it. Now I just looking at the time, I think we are already at 2 hours recording time. So time flew by. I think I wanted to test out this example. I think it's mostly gets, so I think I will. Well, I think we covered all of that now anyway while testing, but let's still do that as a final exercise. And before we wrap up, let's just say, actually, let's test that with the non-partitioned store, clicks global stream store. So then we have covered the global part as well, and we can just verify, confirm one last time that all of our designs and data models should hold and work. So let's use the click global stream store, which should be empty, and we can just reboot the partition here, and also here. Let's now follow the example. So we have from 0 to 4, we have $8. 0 to 4, $8. Then we have 4 to 14, 17. We have $10, 17 to 38. We have $12, 38 to 53. We have $11 and 53 onwards. We have $9. Okay, I think that should be fine. Let's insert those records. Nope. Partition. Okay. Where a key equals curry. Here we got all our data. And now let's test our examples. So get latest would be our select by key, and valid 2 equals -1, which well obviously returns our select star. Let's use also our detect the time we don't need. So here we got our key query, $9 valid to from 53 to -1, which is time 53, $9, correct. Then we have as of time 60, we would have the same query valid to what did we use usually for exact lookup? This should be correct at valid to 60. Order by valid to ascending, limit 1. So we here, we should get, right. Well, the pattern would be we always first fetch the latest, and if it satisfies, here we cannot solve it with a query, but our access pattern within the state store will be always fetch the current value. Current value will tell it's valid from 53. So if we compare that in our implementation in the Java code, not with the query, that 60 is after 53, then we return that current value. So we can satisfy the second as well. And then only the third, when we now go before time 53, we would fetch the latest. We can see it's valid from 53 onwards, which does not satisfy. So we would do a second query where we say valid to larger or equals 50. And now we should get our $11. Yep, here we go. With the valid from 38, which is correct. Yeah. Then as of time 35, we should get $12 valid from 17. Was it 35? $12 valid from 17 seconds. And well, here, if we select 30, right now we did not clean up, but we could say, well, we could now say at that current time we would use, we would do such a range delete after the last write. So let's simulate that as well. After writing all of that data, when we did process the last entry at like I don't know, 53 seconds, I would assume this window here would be, I think that should be 30 seconds retention time. So I think at the point in time of 53 seconds, we would delete everything that was before 23 seconds. So delete from clicks global case stream, key query and valid to smaller than 23 seconds and greater or equals 0. If we now run that and do again, like select all our records, we should now have less records than we had originally. Because those first two should be gone. Yeah, so we only have the $12, $11, and $9 records left. And if we do that final query as of time 30 now, then we should get an empty result. No, we should not. Wait, let's double check. As of time 30. Okay, maybe the example here is wrong, or maybe we need to validate. I think actually what happens here is we should validate the as of time at the time of when this method is accessed, comparing with the stream time, and if the as of time is smaller than stream time minus retention time, I think we should not query the database and say it's outside of our retention range window, and we would not we would not return a result, which is, I think, probably also what should be described here, I guess. Yeah, if no such record exists, including if the provided timestamp bound is older than it stores history retention time, it will return null. Okay, I think that's probably the reason why in this example they say it should return null, just by definition of looking at the window time and the query time. So this is more like a process thing we need to consider when we actually implement the store. And I think that's it. I'm going to wrap up and take a break now. And in the next part, planning to start like a test development fashion to start to create integration test for the new version store. Integration test with my current setup in the project, which is using test containers. So I think we actually will just implement this flow, maybe even a bit more detailed, inserting the records, maybe also do some tests for the point in time delete or point in time put, and also out of range put, and all of those details. So we will write our tests, which should then all fail, and I think that would easily fill probably another long kind of live coding session. And finally, in the part 3, we will then also write the actual implementation, which with all of that work done up front, we should be set up quite well to rock that through. Yeah. And with that, thanks for watching. Stay tuned. Please subscribe to the channel to not miss the exciting part 2 of writing integration tests for the version store. And see you next time. Enjoy your weekend, and bye-bye.